Okay, great. Okay. So hello everyone. My name is Muhammad Ali and I will be presenting alongside my colleagues Sam and Jamie our MEC 674 project, which is about green transportation infrastructure. So in our presentation today, we first aim to clearly present this topic, why we chose this topic, and why it was basically a topic of interest to us by focusing on the problem in the green transportation industry, which would then paved the way to us talking more about the three main solutions that we chose and how we came about choosing them. And after introducing each solution, Sam, Jamie, and I will then move on to deep dive into each solution, then compare them based on a decision matrix which we generated, and finally conclude by defining and recommending the optimal solution for the problem in this industry. So let us get started. Okay, so to begin with, our choice of topic was, as mentioned before, the green transportation infrastructure, in which we focused on electric vehicle charging methods. Before directly talking about the solutions, I want to first talk a bit more about this topic and why it was of interest to us. To begin with, this industry, which is the electric vehicle charging one, has some existing valid and justifiable problems in it, which helps us identify it as a topic of interest. And these problems can be divided into three main ones. So the first problem is that there is a lack of convenience in setting up the station. The second problem is that there are limited charging speeds. And the third problem is that there is a lack of standardization. Now, what do we mean by that? Going back to the first problem, which is the lack of convenience in setting up these stations, there are currently many countries who have an increased number of EVs, of electric vehicles, yearly. However, barely any stations to cover this increasing demand. And this is mainly due to the fact that it is inconvenient to set up the stations because of the fact that there is insufficient charging infrastructure locally available in these countries. This then forces the investors to import the infrastructure, which makes the initial investment prices extremely high. And then in return, this causes the price on the consumers who want to charge their electric vehicles to be extremely high as well. The second problem, which is the limited charging speed, the existing traditional stations also have a sort of slow charging speed, which affects the consumers. It causes them anxiety, it causes high waiting times, and it overall makes these stations seem unreliable, and hence the consumers use these stations less and less. Lastly, for the third problem, which is the lack of standardization, what we mean by this is that there is not necessarily one charging station that can account for any electric vehicle due to the fact that the electric vehicles themselves are manufactured differently. So in return, the charging stations account for different types of electric vehicles based on their different charging ports. Now, because of these three problems, we know that the solutions that we need to propose need to be universal, which would tackle the standardization problem. They need to be fast in terms of charging speed, which would tackle the low charging speed problem, and somehow not too demanding in terms of the infrastructure, which would tackle the first problem, which is the inconvenience in setting up these stations. As a result of these three main criteria, which were we were able to identify three solutions. As you can see here, we have the wireless charging solution, solution A. There's the solar power charging solution, solution B, and the battery swapping solution, which is solution C. I'm going to provide a quick overview on each solution, but then later on, we'll be providing a deep dive into each one of them. So as just a quick brief overview on the first solution, which is the wireless charging. Wireless charging is basically a method in which the energy needed to charge the car is transferred from the station to the battery of the electric vehicle without the need for any physical connectors or cable, hence the name wireless charging. This technology is basically based on electromagnetic fields between the transmitter, which is the station in our case, and the receiver, which in our case is the battery of the electric vehicle. This method, what makes it great is that it does not take too much space. It is very convenient for the users, and it is quicker than the traditional methods and hence overall user-friendly, which reduces the anxiety problems that many users currently face. As for the second method, the solar power charging stations method, these are basically stations that utilize the energy from the sun, a renewable energy, as the main power supply. By making use of the photovoltaic effect and the solar grid, the energy is transferred from the sun into the system and then either directly supplied to the car or it is stored in the battery at times where the supply of energy from the sun is at peak. This energy stored is then later on utilized when the supply of the sun is too low to meet the demand and the demand is too high, meaning that At this time, there will be two power sources, the sun and the battery. And what makes this method great is that it is fast, it is convenient to set up, as most of the infrastructure needed is locally available in most of the countries, and it is reliable at all times because there is a very decreased risk in running out from the energy if these stations are strategically placed and we are utilizing the battery to their maximum. Problems such as inconvenience and then are basically tackled, which would also make this solution viable. And lastly, the third and final solution, which is battery swapping. This solution, as the name suggests, simply consists of swapping the electric battery of your own vehicle, which would be obviously at a low, with a fully charged battery instead that would be available at the station. This method is the fastest of all three methods because the only waiting time is basically the waiting time needed to swap the batteries, which is very short compared to, for example, needing to charge your battery from 0 to a certain number. And there are no requirements from the consumer. The consumer does not have to do anything because the battery swapping process is done either automatically from an automated system or by a professional, which makes the waiting time extremely short and also makes this method a relevant method. Now, obviously, we're going to provide a clear deep dive in
I can't hear you. Do you hear me? Dear students, do you hear me?
Technology that simplifies the recharging process for electric vehicles.
I can't hear you.
The induction process. So a charging station's transmitter generates an alternative magnetic field. When an electric vehicle is equipped with a receiver, it's parked over the charging station, and then the receiver coil in the vehicle can start inducing the electrical current. Then this current can be converted from the alternating to the direct current, and that's what can recharge the EV's battery. So how efficient is it? As you can see in this graph on the right, it's still a bit less efficient than traditional charging, but it has a high efficiency. So we're gonna look more into it now. We had a technical evaluation of the mechanical aspect. So for the mechanical aspect first, we looked at the alignment and coupling. Precision in aligning transmitter and receiver coils is very important for efficient power transfer because the systems allowing automatic and strong alignment minimizes the energy loss. Then the electromagnetic shielding. An effective shielding contains and directs the electromagnetic fields, and it optimizes the power transmission, but it also minimizes the interference with the other possible electronics. There's the heat dissipation. It's very important to manage the temperature level to ensure that we can have a component for longevity. Then there's the integration with the vehicle design. So it must be integrated seamlessly into the electrical vehicle structure, because we need to ensure an efficient power transfer, but also maintain vehicle structural integrity. There's also the protection against environmental factors, of course, because the whole purpose, one of the main purposes of this project is to be environmentally friendly. So it's the wireless charging needs protection, as we said, from elements like the moisture, like physical damage, to ensure the safe and reliable operation in various conditions. And finally, the user experience. This criterion is not exactly a mechanical one, but the user interface design for wireless charging is very important for a positive user experience. So it's good to collaborate between mechanical engineers and to make the experience is very good. Now for the productivity and efficiency. The wireless charging enhances productivity by allowing electrical vehicles to recharge very easily, as we said. And the elimination of the manual plug-ins reduces the refueling time and the effort for the owners. So it's a hands-free charging, as we said. The user only has to park on the area and the car can start charging, and it's very convenient. So if you can imagine yourself in a car and then you have to get out of the car to charge your car, it becomes a bit annoying. And if you can have the privilege to only park on the area and then your car starts charging, it would be that's what makes it very user friendly. So traditional charging methods require you to go out of the vehicle, and wireless charging can simplify this process, and it handles many charging operations in the wall box, so it reduces the complexity in the vehicle. Now about the environmental impact, we looked mainly into three aspects. So there's a reduced fossil fuel dependency, because wireless charging aids in reducing this dependency by promoting the adoption of electrical vehicles. And obviously these vehicles do not rely on internal combustion engines. There's also the mitigation of greenhouse gas emissions, because wireless charging contributes to lower greenhouse gas emissions associated with transportation. So EVs charged with clean energy sources, because they're always the charging method makes it clean, reduces the carbon footprint. And there's the integration of renewable energy. So the wireless charging supports the integration of renewable energy sources, and it reduces the environmental impact on electrical mobility. Now we're going to look a bit into the economic analysis. So the initial installation costs seem to be high, but what we can notice is that the revenue, which is the charging fees, which is what clients, like the customers, have to pay to be able to charge their cars, seems to be very high over 5 years, which for a year makes it about $800,000. And there's also the government incentives. So what we can notice is that it has a very high CER value, which is interesting for us, and a high net present value. And but of course, it's important to notice that we always need maintenance to keep it good all the time. So the value would be around $60,000 for what we looked into. So now we also took a case study in Oslo, Norway. So Oslo adopted wireless charging for electric buses, and it enabled stationary charging at the bus stops. The wireless charging system ensured that the buses had schedules, and they had to adhere to the schedules punctually, and it optimized the overall transportation efficiency. And of course, it had a very good environmental impact. So we had a significant reduction in the air pollution and in the noise, and they had a cleaner and environmentally friendly environment. And it also benefited them for the costs. So they had lower maintenance and operational costs for electric buses compared to traditional diesel parts. Now we're gonna move on to solar power charging stations.
Great. So thank you, Jamie, for this analysis. Now, in a similar way to how Jamie deep dived into the wireless charging solutions, I will be doing the same for the second solution identified, which is the solar power charging solution. Now, to begin with, just as a quick reminder, this solution is a solution, as I mentioned in the introduction, in which the energy from the sun is utilized and harnessed through the photovoltaic effect. It hence relies on natural sources, and this method is extremely reliable since it is able to store the energy during peak day times and then supply this energy when needed, mostly during times where the sun supply is low and unable to cover for the current demand. As a result, solar power charging stations are almost always reliable, either because the sun is providing the power or because the battery has already stored an excess amount of energy and is providing it itself. Now, what are the key components that are needed in order to make this method work? Solar power charging stations have 6 main components, which are solar panels, the maximum power point controller or the MPP controller, batteries, an inverter, a distribution board, and the charging station itself. Basically, the solar panels are there to harness and capture the solar energy from the sun and then convert it into direct DC electricity through the photovoltaic effect. As for the MPP controller, it is a very crucial element, as this is where the energy harnessed from the panel is either stored and hence supplied to the consumer, or both. The job of the MPP is to continuously adjust the supply of the panels by optimizing how much energy is being stored and how much energy is being supplied to the car. What I mean by this is that, for example, in periods of low demand, the MPP is able to increase the amount of energy stored and decrease the amount of energy supplied because the energy demand is low. But during periods of peak demand, the MPP adjusts this by increasing the supply and decreasing the energy stored into the battery, all while making sure that to the end user, everything seems normal. And also there is the inverter. So the inverter is, there is the inverter, the distribution board, and the station in which the DC energy from the station is converted into an AC energy to ensure that it is compatible with the electric vehicle and then supplied through the distribution board and the charging station to the car. By combining all of these together, we are able to set up a solar power charging station. However, because we want to make sure that the solar power charging station is reliable and we can always make use of it, there are three main requirements to consider. First of all is the strategic placement of these stations. We need to place them in high sunlight intensity locations to be able to account for higher energy storage and supply. We also need to place them in spacious locations, which would allow us to use larger solar panels, which would hence allow us to supply and store more energy. And lastly, the stations need to have a standardized semiconductor material based on the space available. If there is a high enough space, we can use a polycrystalline semiconductor material, while if there is a low space, we can use a monocrystalline semiconductor material. And by basically adopting to the standards, we tackle the problem of standardization, and at the same time, we make the panel easily maintained and replaced in cases of malfunction. With that being said, we can now move on to the technical analysis of these stations. Okay, great. So now that we have understood how these stations work, let us take a look at their performance and whether or not they are really reliable stations that can replace the traditional ones. By performing a technical analysis and simulating a solar power charging station on MATLAB, we were able to see that the voltage output and basically the power output is enough at all times during the day, making them reliable sources of energy for the electric vehicles. How exactly did we do the simulation? The input conditions were chosen as 25 degrees for the temperature, and the solar irradiance was varied to match the solar irradiance during the day. And as mentioned, the results were satisfactory. The voltage output during both peak times during the day and during non-peak times, so basically at night, were enough to charge the electric vehicles, meaning that from a technical standpoint, the method is working properly. Now we just need to look more into the economical analysis and the environmental impact of the solar powered charging station. Okay. So in terms of the economical analysis, the initial cost for these stations is around $2.5 million, which would account for approximately 6 or 7 electric vehicles. Now, the initial investment is a bit high. However, when it comes to the charging fees, which are the fees that the consumers pay in order to charge the vehicles, they were found to be approximately $550,000 yearly, while the operating costs are $100,000 yearly, and other revenue streams which come from the subscriptions, premium services, and even in cases where the consumer themselves want to sell their excess of energy, the additional revenues can come at a revenue of $50,000, meaning the annual profit would be around $500,000, and hence the NPV is found to be around $2.4 million and the CER to be 0.9636. This means that although the CER is not exactly 1, or it is not higher to 1, it is very close to 1. And with slight adjustments, mostly through the reduction of some of the costs and the initial investment, there is room to increase the NPV of these stations and therefore increase the CER to values beyond just 1. While this is not currently the case, this is very good and proves that from an economic standpoint, these stations may be a great solution. As for the environmental impact, the utilization of these stations seems to provide really great results, especially when it comes to both reduced carbon emissions and energy savings. So for the carbon emissions, the carbon footprint associated with electric vehicles charging is greatly reduced due to the fact that the energy from the sun is utilized instead of relying on fossil fuels, meaning that greenhouse gas emissions are greatly reduced, which helps fighting the climate change problem currently happening. In a similar way, there is energy savings from these stations because the reliance on the sun as an energy source means that the non-renewable energy sources that are becoming scarce day after day are less exhausted. And also, the third environmental impact is not very great. There is a minor issue that comes with the manufacturing of solar panels, which is the key component of these stations. The manufacturing process requires an extensive energy usage with the use of certain chemicals. Now, although this is being mitigated day by day, it is still an important environmental aspect to consider. All in all, solar power charging stations have been found to be reliable economically, socially, and environmentally, which so far makes them a great solution to the problem in the electric vehicle charging industry. Now, Sam will present the third and final solution, which is battery swapping.
Okay, hello, how are you? So I'll be presenting our third solution to charging electric vehicles, which is battery swapping stations. Now, first, as an overview of what is battery swapping, basically it's a method for recharging electric vehicles, and like the main idea when it comes to battery swapping stations is like the main advantage is that we're able to reduce the waiting time and the time it takes for a vehicle to charge, simply because we remove the charging altogether. And it's basically, first of all, we remove the depleted battery of basically of an EV car. Second, we install a fully charged battery, and finally we recharge the depleted battery in order to keep the cycle like to keep it moving. For battery swapping, the first thing, as previously mentioned, is that we're reducing prolonged recharging waits. The second thing is that we offer efficient refueling for electric vehicles. And finally, we are able, but we're going to like expand on that later on, to enhance productivity and to promote convenient electric mobility. Now, what are the key components of battery swapping? First of all, we have to have a certain battery storage in order to store all of the batteries that are being removed and then fully charged. Second thing, we need a robotic or mechanical system that's going to basically handle, or either a professional, as previously mentioned by Muhammad Ali, in order to remove the depleted battery and to replace it with a fully charged battery. And finally, we definitely need a charging infrastructure to take care of charging the batteries. Now, the three main components that we need to keep in mind for the infrastructure is that first, we need a strategic placement for battery swapping stations because we have to have an optimal accessibility for customers along high traffic areas. The second thing is also very important. Since we're going to a battery swapping station, we want a certain battery standardization in the market. So there are different types of batteries, different materials used for batteries, different dimensions, etc. But going to a battery swapping station, it's better in the market to have this certain battery standardization in order to be able to accommodate all customers and all potential EV vehicle, electric vehicles that we can handle. And finally, we need to have a reliable power supply and to maintain our charging of the batteries. Okay, so as previously mentioned, our main advantage when it comes to battery swapping, it's that basically we really are decreasing the swapping time compared to traditional charging. So it can go as 6 times or sometimes 5 times lower than for traditional charging. Since we remove, as previously mentioned, altogether the process of charging from the equation, we're just replacing a battery that's depleted by a fully charged battery, and then we charge our battery storage again. So this graph shows exactly how time savings is achieved, which is once again the main advantage of battery swapping, but it definitely comes with its disadvantages too, which we're going to deep dive into later on. Okay, so let's do a technical evaluation of battery swapping stations and look into the environmental impact that it has. First of all, for the technical evaluation, we're going to analyze the efficiency of battery swapping stations. First of all, since we do not have any charging cables, any cables in the process of battery swapping, we have minimal charging losses. So there's no resistance, no heat being generated, which means that we have a higher efficiency for battery swapping. Second thing, we have reduced grid impact. So grids would be basically energy distribution systems. And since for battery swapping, we don't have a peak demand. So for example, for other traditional charging methods, potentially several cars could come at the same time, so during a peak time of the day, and all charge at the same time, which would definitely make the grid less reliable. While in our case, it really doesn't matter because a customer who would come wouldn't be charging, even if it's at a peak time of charging, the battery would have been charged beforehand. So that means that we can distribute our charging of the batteries throughout the day. There's no peak dependence on the grid, which makes it more reliable. And we have an optimized vehicle utilization. What do we mean by that? It's basically, since we're reducing downtime, since it takes less time for a vehicle to be basically charged in a way when it comes to battery swapping, it's like around 10 minutes, which is really low. That means that we can use our car or vehicle in general for more time. So reducing downtime, which can be very important in terms of productivity. We'll look into it later. And finally, it's definitely very convenient for users to have very low charging time, which is definitely a priority for EV users. Now, for the productivity, as previously mentioned, what's the main consequence of reducing downtime? It's optimizing fleet operations. So for example, whatever business, transportation, for example, delivery system or whatever that relies on electric vehicles would have reduced downtime if they go for battery swapping, which means that since they reduce the time it takes for a car or for whatever vehicle they're owning to charge, they're increasing the utilization of this vehicle, which means that they're optimizing their operations. And for a business, would it be in terms of transportation or delivery, it's definitely something like that they would want. And for the environmental impact, we have definitely two main things to take into account, which is sustainable sourcing and renewable energy integration. So when it comes to the environmental impact of battery swapping station, it's all about how it's taken into account for how sustainable we're being in the process of battery swapping stations. So for example, do we have batteries that we're using? Do we have sustainable batteries? Are we sourcing in a environment-friendly way? And for the renewable energy integration, so the batteries that we're actually charging, how are we charging them? Is it renewable the way we're doing it or not? As you can see on the graph on the right, sometimes it's not. So sometimes businesses do not rely on sustainable alternatives when it comes to charging their batteries or even sourcing their batteries, which means that the CO2 emissions for battery swapping that are per kilowatt hour, as you can see in this graph, can be 2 or even 3 times higher than for traditional charging. So for battery swapping, the concerns are about its environmental impact, but it definitely has a positive impact when it comes to reduced charging time, which means less downtime and more productivity. Okay, so finally here we can see our economic analysis and case study. For the economic analysis, we definitely have a high initial cost, which is across the 3 alternatives, the highest one. It definitely is because we have to simply construct a station, potentially even 2 stations. We have high initial investment also because we have to purchase the batteries, etc. So that's our initial investment, but we also have high operating costs due to definitely the maintenance of the batteries, the replacement of the batteries, our utilities to electricity since we have to charge them, but also potentially we have labor costs in the case where the battery removal and replacement is being handled by a professional. For the charging fees, we basically took a basis of $20 per swapping, basically, and we assumed around 50 swappings a day, which is reasonable and based on previous research. That's like we benchmarked, and that's the range that would be of interest, so around 50. And for the 50 swappings multiplied by 20, we obtained a total of $1,000 per day per station. Now that amounted to a total of 730,000 across 2 stations, if we consider that. And we also considered $500,000 incentives, one-time incentives, and battery replacement over 5 years. So that gave us an ROI of 4.29% over 5 years and an NPV of around 2 million, which yielded a CR of 0.63. Now, we deep dived into Better Place, which was a battery swapping station. Now it closed basically, but it used to operate, and they usually advertise as taking less than 5 minutes in the charging time, so not even 10, but 5 minutes. However, the environmental impact of the station was relatively considered bad, since we had an estimated 20% increase in the carbon footprint. And we can see that the high initial investment, like it was around $1 million per battery swapping station, made it really difficult for the owners to keep running for more years. Okay, so now we're going to have our comparative analysis across the 3 options. Solar charging, battery swapping, and wireless charging across 3 main criteria, which are the economic perspective, the environmental impact, and finally, how practical it is and how convenient it is for the user. Now, first of all, for the economic perspective, as we previously mentioned, the higher initial investment, the highest one actually, would be for battery swapping, which means that we definitely have a vital need for government incentives. But we can also generate relatively high revenues if we do charge at $20 per swapping. For solar charging and wireless charging, the initial investment is lower, but still it's significant. And we can see that we can have a long-term ROI, which is relatively attractive for solar charging, but also, and more importantly, for wireless charging. Now, for the environmental impact, it's like the least optimal environmental impact, again, would come for battery swapping, since, as I previously mentioned, it depends on the carbon footprint and at how we source our batteries, at how we basically, whether we integrate renewables in the charging of our batteries. And it would be the best environmental impact when it comes to solar charging, which definitely would reduce emissions, while at the same time, it does not rely on fossil fuels. And finally, for the practicality, it depends again on the case we're considering. Battery swapping would definitely be more optimal when it comes to fleet operations and when it comes to wanting to increase productivity. But the fact that it has a low environmental impact makes other options such as solar charging or even wireless charging better. So we're going to now move into our next slide, which is concluding on the matter and recommending. So we have 4 main recommendations here. The first one is to consider specific use cases. So as I previously mentioned, we have different basically practicalities for different uses that we can have for those 3 different types of battery charging methods. So our objective here is to tailor the method depending on what needs we have in the market. If we want to optimize productivity, then we would go for battery swapping. If we want to decrease our carbon footprint, then we would have to go for solar. If we want to have a profitable investment, then we would have to go for the one who would have the higher NPV and thus the higher CR, which is wireless charging, etc. We definitely have to take into account geographical location, environmental impact, but also budget constraints. For the second one, it's about leveraging renewable energy. It's about integrating clean energy sources in order to reduce our carbon footprint, but also about looking to for governments to incentivize our clean energy adoption.
Okay, so next we looked at the complementary approaches. So if it's possible for us to combine several charging methods to make EV even better, but it would need, of course, a very detailed study to make sure of what we can combine, what we can benefit from, or what would be more costly, more environmentally friendly. And but it's one of the recommendations that we can follow in the future. And then the government support. This one is important because, of course, for the government of all the countries, it would be very important for the government to know that the environmental impact is becoming better, and it would give them an incentive in helping, maybe financially or like with any way for the project to make it work. And then we made a decision matrix to compare the several alternatives that we mentioned. So we took some criteria, which are initial cost, CER, CO2 emissions, charging speed, and convenience, and then we calculated the total score. But it's important to mention that the weights that we put would vary by maybe a lot, depending on the owner of the project, what are his specific needs, what exactly is needed from this project. So we put some weights that we found would be logical, but of course it can vary. So the score wouldn't show exactly which one is the better. So for the initial cost and the CER, wireless charging was the best because, and we used the formula that we learned in class for CER, which is we do the number, which is, for example, $2,500,000 minus the worst over the best minus the worst to give scores for each of them. And for the ones that are qualitative, we saw how much they're better than the others to give. We had the score over 10, and that's how we calculated the score over 1. And then, okay, for the CO2 emissions, for example, solar power charging is environmentally friendly. It relies on renewable energy sources, so the sunlight, and this reduces the CO2 emissions. For wireless charging, it depends on the energy source that is powering the charging station. So it can vary, but it's relatively clean. And for the battery swapping, it depends on the energy mix that is used. So it can have higher emissions than solar or like the other alternatives. So then for the charging speed, we saw